This is Engage New York, Module 3, Lesson 5. Read the objective while I read it out loud. I can subtract fractions with unlike units using the strategy of creating equivalent fractions. So that is the big idea. That's why we're creating those models, those fractional models, is to show the rectangular fraction model is the strategy of creating equivalent fractions. And that is the big idea of changing units and creating a common denominator. So we're changing directions. Instead of adding, we're going to be subtracting. We are going to start out with a sprint. We're going to be subtracting fractions from a whole number. So what I want you to do is I want you to take out your book, your math textbook. Do not lose. Take this out. So subtract. Give each answer in its simplest form. So 4 subtract a half. 3 subtract a half. So we're subtracting, and we're subtracting from a whole. All right, are you ready? Pencils up. Ready, go. Okay, are you ready to debrief? All right, so my strategy on this one is just is to take away just half from that whole number. So the first couple are quite easy. 3.5, 2.5, 1.5, half. Now, my strategy for here is, in my mind, I was turning that whole number into a 3 over 3. So 3 over 3 is really 1. So 3 subtract 1 is 2/3. So I was going 1, 3 over 3. So 1, that was my strategy. So I'd go 3 and I go 3 over 3. That's how I was solving that in my head. So 2/3, 1 and 2/3, 3 and 2/3, 3 and 1/3, 1 and 1/3, 1 and 3/4, 1 and 1/4, 2 and 1/4, 2 and 3/4, 3 and 1/4, 1 and 1/9, 1 and 9/10, 2 and 1/10, 1 and 3/10, 3 and 7/10. So once you get that common denominator, you have that denominator down, all of a sudden you can start thinking a little bit more quickly, like 1 and 10 over 10, right? Okay, 2 and 1/10, 1 and 3/10, 3 and 7/10, 2 and 4/5, 2 and 3/5, 2 and 1/5, 2 and 2/5. All right, how did you do? Can you now see the strategy that I used in order to do that in my head? And I was just doing it in my head. So I'd pull a number off and then turn whatever was left. So I'd pull 1 off and turn that into that 1 into a fraction. All right, so you want to try it again? See how you do this time? All right. All right, get ready. 1, 2, ready, go. All right, I got a few more, so I improved by 3 this time. So once you get into the hang of it and you get in that groove, it starts coming a lot faster. So 1/2, 1.5, 2 and 1/2, 3.5, 3/4, 1 and 3/4, 3 and 3/4, 3 and 1/4, 1 and 1/4, 1 and 2/3, 1 and 1/3, 2 and 1/3, 2 and 2/3, 3 and 1/3, 2 and 9/10, 1 and 1/10, 3 and 3/10, 2 and 7/10, 1 and 4/5, 1 and 3/5, 1 and 1/5, 2 and 2/5, back up, 1 and 7/8, 1 and 5/8, 1 and 3/8. All right, so part of your work is to go back and finish the sprint, right? All right, so go ahead and take that and put that off to the side. Now we're moving back to our fluency. So in our fluency is the application problem. So a farmer uses 3/4 of his field to plant corn and 1/6 of his field to plant beans, and the rest to plant wheat. What fraction of his field is used for wheat? But first, you need to figure out the farmer uses 3/4 of his field to plant corn and 1/6 of his field to plant beans. And then the rest is to plant wheat. So it looks like this is a multi-step problem to me. Now, what is the strategy that you're going to use to make your common denominator? So hopefully you just said you're going to scoreboard. So you have 1/6 and 3/4. So you're going to have 6 and 4. And you're going to scoreboard, right? I want you to show me what you're going to do here and come back. And you're going to show me using, you can have your two fractions. If you want to split this up in two and create two rectangular fraction pieces, rectangular fraction models out of this one, feel free to do so. But however you want to use what I've given you is perfectly fine, but you want to get in the habit of being able to use those fraction models to show equivalent fractions as well. All right, check back after you worked on it and see how you did. All right, so if you can see, I started off with just scoreboarding. Now, 6 and 4 have several, they have 12 and 12. I could have gone out a little bit farther and I could have gone 16, 20, and I could have gone all the way out to 24 and used 24 and 24. But 12 is the smallest. It's the smallest denominator. It's the smallest unit that they both share, like the smallest product that they both share. And that's what we're always looking for, trying to find the smallest product that they both share. Now, what I did is, because I know I'm going to use 12 as my denominator, I came over here and I knew that 6 times 2 is 12. So I multiplied the top and the bottom by 2 to my 1/6, and I created 2 12s. Then over here, I knew that 4 times 3 is 12. So I came over here and multiplied 3 to the top and the bottom of my 3/4. So now I have 9 12. So now I do have like units. They're sitting now on that same number line. Before, this was on the 6th number line and this was on the 4th number line. Now we've taken that and created equivalent fractions and now place them on the same number line so we can add or subtract. So I have 2 12s plus 9 12s is 11 12s. Okay, so now let's come over here. So I took my box, my rectangular fraction model, and I cut it up into 12s to start off with. Then I knew that 2 12s belonged to the beans, and I knew that 9 12s belonged to the corn. So what's left? Well, 1 12 is left for the wheat. So now how do I find that? Well, I have to take the total, which is 1 whole would be 12 over 12. And the reason I'm using 12 over 12 is because in order to add or subtract, you have to have like units. You have to use the fraction. If you're going to use 1 whole, it has to be the same number over the same number, right? You have to have 12 of 12, 10 of 10, 11 of 11, 8 of 8. So in this instance, we're working with 12s. So I have to go 12 over 12, and I'm going to subtract how many I've taken up, and that's going to give me 1 12. 1 12 of his field is used for wheat. So the correct answer is 1 12 of his field is used to plant wheat. And remember, that's what we're going for. This is the answer that you're providing, not just the number. You're actually answering the question. All right, that's going to do it for fluency. come on back for concept development, and remember what our objective is when we come back. It's subtracting fractions with unlike units using the strategy for creating equivalent fractions. All right,